Friday, I'm going to go through some common things that I noticed from the week. So first up, when you did your Google form after you watched my video about AP exam logistics, a lot of people did not check the following three things that are really important. So I'm going to remind you to do these if you haven't yet. Make sure you're getting emails from College Board. If you're not, you need to go to AP Classroom and you need to go to your profile and you need to fix your email address on there and click subscribe if you haven't already to emails. Also, if you don't know how to find your AP ID, Google it, AP ID College Board, how to find. How can I access my AP ID? It's right there for you. Okay. I'm not going to read it because you can read it when you Google it. Also, you need to try the demo that I talked about in the video and that there's a link to in that document from Monday's assignment. I want you to know what to expect from the exam, what it's going to look like, and I want you to practice uploading answers. Are you going to type, copy, paste? Are you going to add a document? Whatever you're going to do, practice it. So on test day, you're not trying to figure that out for the first time. If you have questions about any of that stuff, reach out to me. Send me an email. Okay, next up, your Tuesday assignment was all about reviewing the labs that we did this year. Overall, it looked pretty good. I can tell that these labs were meaningful for you and they really stuck in your brains. That's awesome. I just want to talk about the controls because that seems to be something we're struggling with. Independent and dependent variable looked pretty good overall, but I'm going to go through the control for each of the experiments. So for the limits to cell size, appropriate controls that you could have said are the 1x1 cube that we used because we compared everything to that. You could also have said putting the agar into water to verify that the color change was due to diffusion and not just happening on its own. So anything in which you're comparing to validate the conclusion that you're trying to make, that's a good control. Potato core lab could have been putting the potato core in straight water so that you have kind of like a reference point. That's fine. That's a valid control to have listed. Photosynthesis spinach lab from the Saturday session, it was really the spinach being in the dark because that showed us the rate of CO2 production from the spinach leaves without photosynthesis happening so that we knew how much CO2 was actually produced by photosynthesis once we turned the light on. When you did your open inquiry, different people had different controls. If you varied the amount of light, possibly your control was one light bulb. If you varied the amount of spinach leaves, possibly your control was one spinach leaf. It depended on what you did for your open inquiry. For the enzyme lab, the filter paper placed in water was our control. So making sure that that filter disc did not rise without enzyme on it, or we could have put the filter paper with enzyme on it into water, making sure that the substrate had to be present for that filter paper to rise. Massive plant lab, everybody's was different, but possibly having the plant in the dark or having the plant without water or having the plant in normal conditions, and then you varied different things to see how it impacted it. It was one of the conditions that you set up that you compared to. Cellular respiration lab, for the first round, it was the ungerminated mung beans. So we can see the difference between the ungerminated and germinated. Maybe like this person did lima beans. So their control for their open inquiry was the regular lima beans ungerminated. And then they compared that to the germinated lima beans. For the Vertex GMO lab, our control was tubulin. We used tubulin to make sure that our PCR worked because all of our foods should have had tubulin. And then that allowed us to see validly whether the GMO band was present or not, but we needed to see that the PCR worked by seeing the tubulin. For the forensics lab, the culprit's DNA was really our control because it's what we were comparing to. So the control is always what you're comparing to, okay? Next up, cell cycle regulation question. So the first part, it says a skin cell completes one round of the cell cycle. Describe the products. It just wanted you to say, like, there's two cells and they're identical and they have the same amount of DNA. Okay. Based on figure 1, explain how P53 regulates the cell cycle. So I'm looking at this figure. I'm seeing P53 seems to be going onto the DNA here and moving this way, and it seems to be producing CDK inhibitor. Okay, so P53 makes this CDK inhibitor, and so the inhibitor is going to inhibit CDK, meaning it's going to stop the cell cycle from happening. Because we remember from my review video, if you haven't watched it, go back and watch it. CDK plus cyclin they both need to be present for the cell to go through the cell cycle. C, I made a comment on the assignment that I was looking for the phase of the cell cycle where the replication of the damaged DNA would occur. DNA is replicated in S phase. Okay, so I was looking for you to say S phase there. And then based on the figure, explain how a mutation to P53 may lead to an increase of cancer. So if P53 is not working, then the CDK inhibitor is not being produced. So there's nothing stopping the cell cycle. So the cell's going to keep copying even though there's that DNA damage, and that can lead to cancer. Cancer is cells with DNA damage that keep replicating and don't stop replicating. Yesterday, Thursday's FRQ was all about cellular respiration, and there was some like genetics thrown in there. Part A asked you to describe a pattern of inheritance. So this depended on you noticing that MTND5 is a mitochondrial gene. So if it's in the mitochondria, we only get our mitochondria from our mom. So that's the pattern of inheritance. You're only getting this gene from it's only maternally inherited. It's only from your mom. How come you can't be heterozygous? Because if you're only getting one copy of it from your mom, you're not getting a copy from your dad. That means you can't be heterozygous. You just have one copy. Dependent variable, always the y-axis, okay? A lot of people were able to just write down what they saw on the y-axis. You could have identified either this or this. A control. So again, people are struggling with control. We got to keep practicing that. They said here that they only tested individuals with the disorder. So a possible control would be to test individuals without the disorder. Another possible control could be to give people a placebo and see if it changes their lactic acid and NAD+ concentrations. Justify the researcher analyzing blood samples at many points. The more data you have, the more valid your conclusions. Period. The end. Describe the relationship between the concentration of NAD+ in the blood and the concentration of lactic acid in the first 5 weeks. All I have to do is look at the graph for this. I'm pretty sure there's going to be a question like this on the AP exam. So make sure that this makes sense to you. I'm seeing first 5 weeks, 0 to 5. 0 to 5. Okay, all I have to do is say NAD+ increases, lactic acid decreases. That's it. That's all it's asking for. It's right there in the graph. And then calculate the average rate of change in blood NAD+ concentration from weeks 5 to 17. So this is just finding the slope. When it's asking for rate, it's asking for the slope. So I find 5, that's about 300. And I find 17, that's about 50. So I'm doing 300 minus 50 over 5 minus 17, because that's the week 5, week 17. So I'm just finding the slope. However you best find the slope, do that. And I'm seeing it's negative. So, okay, yes, it makes sense. This comes out to be about negative 20. So my negatives and positives should make sense. And I want to use the units too. Micromoles per liter of NAD+ per week. So you could even put those in here to show yourself the units. Okay. D, researcher performed a follow-up experiment to measure the rate of oxygen consumed by muscle and brain cells, predict the effect of MTND5 mutation on the rate of oxygen consumption. So I went back up here to remind myself, what is the MTND5 doing? So let's see. Okay. The MTND5, blah, 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 encodes a subunit of NADH dehydrogenase, the enzyme that catalyzes the initial oxidation of substrate. Oh, it's the thing that turns NADH to NAD+ and and H plus in the electron transport chain. So that happens when the NADH is dropping off its electrons. So that's like happening at the beginning, that the NADH turns back into NADH plus and H plus. I remember that from the review video and from the model that are both on YouTube. So if there's less electrons entering the electron transport chain, that means there's less electrons coming out of the electron transport chain, and those electrons are picked up by oxygen. So that must mean there's less oxygen being used because there's not electrons to pick up. So let me go back to the question. Predict the effect of the MTND5 mutation on the rate of oxygen consumed in the muscle and brain cells. Okay, less oxygen will be consumed. Justify your prediction. So I would explain how I knew that, which I kind of already verbally did. The researcher had hypothesized that the addition of the vitamin is similar in structure to the NADH, would increase the activity of the mutated NADH dehydrogenase enzyme. This talked about that the vitamin is like a substrate, and increasing substrate increases product. Okay, one additional thing. I know I'm talking kind of fast. Sorry, you can slow me down or replay if you need to. I'm just trying to get it to be a shorter video so you don't hate me for how long it is. So I have all of these videos that I've put this time into making for you, and they're great reviews, and I think you're going to appreciate them. But look at the views. Oh no. Photosynthesis and cellular respiration. 7 out of my 70 students watched it. That's not very good. You guys got to watch the review videos. How many times do I have to say it? It's on you. I can't make you do it, but if you watch them, it's going to help. Also, I want to just remind you of how to find my videos. Type into Google Elizabeth Heisler YouTube channel. So most of them are linked on Google Classroom. But if you want to just find them this way, you can click on the first link. That's me. And then you have all of my videos. So like you could go watch the cellular respiration model that we did in class, me talking through it. Okay. We're in the home stretch. We've got like a week left. You got to really kick it into gear and make sure you're doing the FRQs and watching the review videos. You guys are awesome. Watch the review videos. I'll talk to you soon. Bye.